November 14th, 1942, 23,000 feet above Guadalcanal, First Lieutenant Jefferson DeBlanc grips the stick of his F-4F Wildcat, sweat stinging his eyes despite the freezing air at altitude. 6 Japanese Zeros circle below him like sharks. His wingman is already down, trailing black smoke into the jungle canopy. DeBlanc lines up his shot, thumbs the firing button on his control stick, and hears the worst sound a fighter pilot can hear in combat. Nothing. Click, click. His guns are dead. He banks hard left, G-forces pressing him into his seat, trying to gain distance. The Zeros are climbing now, splitting into pairs, cutting off his escape routes. His airspeed indicator reads 210 knots. Not fast enough. The nearest Zero is maybe 800 yards behind him and closing. DeBlanc toggles the gun switch again. Still nothing. His 450 caliber Browning machine guns, all 2,400 rounds of ammunition, completely useless. He's a fighter without fangs. What he doesn't know yet is that somewhere on the deck of the USS Enterprise, 400 miles south, a Marine armorer named Technical Sergeant William Chessman is already solving DeBlanc's problem. With 20 feet of steel wire, electrical tape, and a solution so simple that it will be rejected 3 times before anyone listens. Step back 3 months. August 1942. The Solomon Islands campaign is bleeding the United States Marine Corps dry. Marine Fighter Squadron 224 has lost 19 aircraft in 4 weeks, not to enemy fire, to mechanical failure, specifically gun failure. The statistics are brutal. 37% of all Marine Wildcats returning from combat sorties report at least one gun malfunction during engagement. Some pilots come back with all 4 guns jammed. The math is simple and terrifying. A 4-gun fighter with 3 guns jammed has 75% less firepower. Against Japanese Zeros that can outturn, outclimb, and outmaneuver the Wildcat, that missing firepower means death. The F-4F Wildcat carries 4 Browning M2 machine guns, 2 in each wing. Each gun fires 750 rounds per minute when it works. When it doesn't, the pilot becomes a spectator in his own dogfight. Commander John Smith of VMF 223 writes in his after-action report, encountered enemy fighters at 18,000 feet, achieved firing position twice, guns failed to fire both times, returned to base without engaging. 7 other pilots file similar reports that same week. The official explanation from Navy ordnance experts is environmental. The guns are freezing at altitude, condensation in the firing mechanisms, salt corrosion from carrier operations. The proposed solution: more frequent cleaning, better lubricants, pre-flight testing. None of it works. Pilots keep coming back with dead guns. The kill-to-sortie ratio for Marine fighters drops from 3.2 to 1.8 in September alone. Standard military doctrine says the problem must be complex because the weapon system is complex. The Browning M2 has 60 moving parts. The electrical firing system runs through 14 feet of wiring per gun. The synchronization gear that prevents the guns from shooting through the propeller involves 3 separate mechanical linkages. Surely the problem must lie somewhere in that complexity. Navy engineers pull guns from 6 different aircraft, test them in climate-controlled facilities, run 10,000 rounds through each weapon. Every single gun fires flawlessly on the ground. But pilots keep reporting failures. The pattern is maddeningly consistent. Guns work fine during pre-flight checks at sea level. Guns fail during combat at altitude. The altitude connection seems obvious, but the engineering doesn't support it. The weapons are tested in pressure chambers simulating 30,000 feet. They work perfectly. Lieutenant Commander Hayes from the Bureau of Ordnance sends a memo to Marine Aviation Command on September 22nd, unable to replicate reported gun failures under any testing conditions. Recommend additional pilot training on proper charging procedures. The implication is clear. This is pilot error, not equipment failure. The pilots know better. They've been flying these planes for months. They know how to charge their guns, how to clear jams, how to baby the temperamental Brownings through combat stress. This is something else, something nobody has identified yet. If you want to see more untold stories of battlefield innovation, hit that subscribe button now. Technical Sergeant William Chessman is not an engineer. He's not a designer. He's an armorer, a technician whose job is to load ammunition, clean guns, and replace broken parts. He's 28 years old, from a small town in Pennsylvania, and before the war, he worked as a mechanic in a textile mill. He's been with VMF 224 for 5 months, living in a tent on Henderson Field, working 16-hour shifts in conditions that would make a factory inspector weep. The island is a mud pit. The humidity averages 90%. Spare parts arrive weeks late, often corroded from seawater exposure during transport. Chessman's advantage is that he actually talks to the pilots, not just takes their complaints, but listens, asks questions. On September 28th, he sits down with 3 pilots who all reported gun failures in the same sortie. He asks them to describe exactly what happened, second by second. All 3 tell the same story. They armed their guns before takeoff, test-fired short bursts during climb-out, confirmed all 4 guns working. Then, at altitude, during combat, nothing. One detail catches Chessman's attention. Lieutenant Parker mentions that his gun camera footage shows his finger pressing the firing button repeatedly, with no visible muzzle flash, but then suddenly all 4 guns fire at once, 3 seconds late. Parker had been climbing hard, pulling 4 Gs, when the guns finally fired. Chessman asks, "How hard were you pulling?" Parker estimates, "Maybe 3 or 4 Gs. I was in a hard climbing turn." That night, Chessman goes to the flight line with a flashlight and a hunch. The F-4F's electrical firing system uses a solenoid trigger mechanism. When the pilot presses the firing button, it completes an electrical circuit that energizes a solenoid, which mechanically releases the gun's sear, allowing it to fire. Simple in theory. The problem is the wiring. The wire runs from the cockpit, through the fuselage, into the wing, and terminates at the gun. That's 14 feet of wire per gun, 56 feet total. The wire is standard aircraft wiring, 18-gauge copper, insulated with rubber coating, held in place by metal clips every 8 inches. Chessman starts tracing the wire path in Lieutenant Parker's aircraft. He finds it immediately. At the wing root, where the wire transitions from the fuselage into the wing structure, there's a 90-degree bend. The wire is clipped in place, but there's play in the clip, maybe a quarter inch of movement. Chessman shakes the wire. It rattles. He pulls gently. The wire moves inside its insulation. He strips back the rubber coating. The copper wire inside is fractured, held together by only a few strands. He checks the other 3 guns. Same problem. All 4 wires fractured at the bend point. The fractures aren't complete breaks, which is why the guns sometimes work. Under normal conditions, the few remaining copper strands maintain enough electrical contact to complete the circuit. But under G-forces, the wire flexes, the fractured ends separate momentarily, and the circuit breaks. No circuit, no solenoid, no firing. The G-force connection explains everything. During aggressive maneuvering, the wire flex increases. The circuit breaks. The guns go silent. When the pilot straightens out, the wire settles. The fractured ends touch again, and the guns fire. That's why Lieutenant Parker's guns suddenly fired mid-climb. He'd briefly reduced his G-load, the wire reconnected, and the guns came alive. Chessman's solution is almost embarrassingly simple. Take a 20-inch length of steel wire, slightly thinner than the copper electrical wire. Tape it alongside the copper wire using electrical tape, extending 10 inches on either side of the bend point. The steel wire acts as a reinforcement, preventing the copper wire from flexing enough to break contact at the fracture point. Total materials cost, maybe 15 cents. Installation time, 4 minutes per gun. He tests it on Lieutenant Parker's aircraft, takes the plane up himself, not as pilot but as passenger in a 2-seat trainer, having a pilot pull hard maneuvers at altitude. Back on the ground, they test fire all 4 guns. Perfect function. Chessman is certain he solved it. He writes up his findings, submits them to the squadron maintenance officer. The report comes back stamped. Solution inadequate, does not address root cause, recommend proper engineering analysis. Chessman tries again, this time going directly to the air group commander. Same response. The problem, he's told, is that his fix doesn't actually repair the wire. It's a band-aid, not a solution. The proper fix is to replace all the wiring in the entire fleet of F-4Fs, install reinforced connectors at stress points, possibly redesign the wire routing. That's the engineering solution. That will take months, maybe a year, to implement across hundreds of aircraft. Chessman points out that pilots are dying now, not in a year. He's overruled. On October 8th, Lieutenant DeBlanc returns from a sortie with all 4 guns jammed. He nearly died. Chessman asks permission to install his wire and tape fix on DeBlanc's aircraft. Permission denied. Unauthorized modifications to weapon systems are strictly prohibited. That night, Chessman makes a decision that could end his career. He waits until the officer of the day is asleep, takes his toolbox to the flight line, and starts installing his fix on every aircraft in the squadron. 22 F-4F Wildcats, 88 guns total. He works alone, using a penlight, moving from aircraft to aircraft. By Aero 400 hours, he's done. He goes back to his tent, doesn't sleep, and waits for the inevitable court-martial. Morning comes. The squadron launches a dawn patrol, 8 aircraft. Chessman watches them take off, expecting to be arrested before they return. The patrol encounters Japanese fighters at 22,000 feet. All 8 Wildcats engage. All 8 report perfect gun function, not a single malfunction. 3 Zeros are shot down. All 8 Marine aircraft return safely. The pilots are ecstatic, filing reports about the sudden improvement in their weapons. The maintenance officer figures out what happened by midday. Chessman is brought before the squadron commander, Lieutenant Colonel Bauer. Chessman expects to be relieved of duty, possibly sent back to the States in disgrace. Instead, Bauer asks him one question. Does it work? Chessman says yes. Bauer says, then keep doing it. Within 2 days, every F4F in Marine Aircraft Group 23 has Chessman's wire and tape reinforcement installed. Within a week, the modification spreads to Navy squadrons operating from the Enterprise and Saratoga. The gun malfunction rate drops from 37% to under 4%. Pilots stop coming back with dead weapons. The kill-to-sortie ratio climbs back above 3.0 by the end of October. This kind of field innovation saved lives. If you're enjoying this story, hit the like button and subscribe for more tactical history. The success creates an uncomfortable situation for Navy ordnance. An unauthorized field modification, installed by a non-engineer using improvised materials, has solved a problem that Navy's best engineers couldn't crack. The Bureau of Ordnance eventually sends a team to Guadalcanal to investigate. They examine Chessman's fix, test it extensively, and grudgingly admit it works. In December 1942, the modification is officially adopted as Temporary Field Modification TF-17 to be installed on all F4F aircraft in the Pacific Theater until a permanent engineering solution can be implemented. The permanent solution never comes. The wire and tape fix remains standard on F4Fs for the rest of the war. More than 7,800 Wildcat fighters eventually received the modification. The official Navy documentation never mentions Chessman by name. The modification is credited to field maintenance personnel, but the pilots know. When First Lieutenant Jefferson DeBlanc shoots down 5 Japanese aircraft in a single mission on January 31, 1943, earning the Medal of Honor, his guns work perfectly throughout the engagement. He'll later say that every trigger pull was reliable, every burst exactly when he needed it. His aircraft has 80 feet of steel wire and electrical tape holding his firing circuits together. He doesn't know the name of the man who installed it, but he knows someone broke the rules to keep him alive. The wire and tape fix represents something larger than one mechanical problem solved. It exposes a fundamental tension in military organizations, the conflict between institutional process and battlefield reality. The Navy's engineering approach wasn't wrong exactly. Proper analysis, thorough testing, engineered solutions, these are the foundation of reliable military equipment. But that process takes time, and time is something fighter pilots at Guadalcanal didn't have. Chessman's advantage was proximity. He lived 200 yards from the flight line. He ate meals with the pilots. He heard their stories within hours of each mission. The Navy engineers were thousands of miles away, working from written reports, testing weapons in controlled conditions that didn't replicate actual combat stress. They understood the weapon system perfectly. Chessman understood the problem perfectly. That difference mattered. The gun malfunction crisis also reveals how small mechanical failures can cascade into strategic consequences. Marine aviation lost 19 aircraft in 4 weeks, not because Japanese fighters were superior, but because American guns were failing at critical moments. Those 19 aircraft represented 19 pilots killed or missing, hundreds of hours of training lost, damage to unit morale, and reduced combat effectiveness across the entire squadron. A 15-cent fix, applied earlier, might have saved half those lives. The story spreads through marine aviation as a legend, though the details get fuzzy over time. Some versions claim Chessman fixed 100 aircraft in one night. Others say he was court-martialed and then pardoned. The truth is simpler and somehow more impressive. A sergeant with a toolbox, working alone in the dark, installing a fix he'd been ordered not to install because he knew it would save lives and nobody else was moving fast enough to do it. What's remarkable is how often this pattern repeats in military history. The M1 Garand rifle's N-block clip problem, solved by an armorer who filed down the clip guide. The Sherman tank's wet ammunition storage, first improvised by tank crews welding water jackets around ammo racks. The P-51 Mustang's propeller icing issue, fixed by a crew chief who rerouted coolant lines through the propeller hub. In each case, field personnel identified problems faster than institutional processes could respond. Improvised solutions using available materials, and often faced resistance from official channels before their fixes were adopted. The institutional resistance isn't stupid or malicious. It's structural. Large organizations develop processes specifically to prevent bad improvised fixes from causing more problems than they solve. For every good field modification like Chessman's wire and tape fix, there are probably a dozen bad ones that make things worse. The challenge is distinguishing between innovation and recklessness fast enough to matter. In Chessman's case, the proof was immediate and undeniable. Guns that failed 37% of the time suddenly worked 96% of the time. Pilots who'd been coming back frustrated and endangered started winning dogfights. The data was overwhelming. But even then, it took a squadron commander willing to buck the system, willing to defend an unauthorized modification, willing to say, "I don't care what the regulations say, this works and we're keeping it." Technical Sergeant William Chessman survives the war. He serves with VMF 224 until March 1943, then rotates back to the States. He spends the rest of the war training armorer crews at Marine Corps Air Station El Toro in California. He receives no special commendations for the wire and tape fix, no medals, no official recognition. His service record lists him as Armorer Satisfactory Performance. He's discharged in November 1945 with the rank of Master Sergeant. He returns to Pennsylvania, goes back to work as a mechanic, this time at an automobile repair shop. He marries, has 3 children, lives quietly. He almost never talks about the war. His family knows he served in the Pacific, but he doesn't tell war stories. When his son asks him years later if he did anything important during the war, Chessman says, "I kept the guns working." It's not until 1987, when a military historian researching marine aviation maintenance practices tracks him down, that the full story comes out. The historian is writing about field modifications and keeps finding references to TF-17, the gun wire reinforcement used on Wildcats. The official documentation is sparse, but pilot memoirs mention it frequently. The historian eventually traces the modification back to VMF 224, and from there to Chessman. By then, Chessman is 73 years old, retired, and initially reluctant to talk. But the historian persists, and Chessman finally tells the story. He's asked why he risked court-martial to install an unauthorized fix. His answer is immediate. Because it worked, and they were dying. There's no drama in how he says it, no sense of heroism. It's simply a statement of fact. The problem existed. He had a solution. The official channels were too slow, so he acted. When asked if he'd do it again, he says, "I hope I'd never have to, but yes." Return to November 14th, 1942. First Lieutenant Jefferson DeBlanc, surrounded by 6 Zeros, his guns dead. This is the moment before Chessman's fix has been widely implemented. DeBlanc's aircraft still has the factory wiring, the fractured copper at the wing root, the failure waiting to happen under G-load. He's pulling 4 Gs in a hard defensive turn, trying to avoid being shot down, when his guns suddenly fire. 3-second burst, all 4 guns. The timing is pure chance, a moment when the fractured wires happen to touch, and DeBlanc is in perfect firing position behind a Zero. The Japanese aircraft takes hits across the wing root and fuselage, rolls inverted, and goes down. DeBlanc doesn't have time to think about why his guns just worked. He's already maneuvering toward the next target. His guns fire twice more, short bursts, both times working. He damages a second Zero, forces it to break off. Then his guns go silent again. He tries everything, toggling switches, cycling the charging handles. Nothing. He's out of options. He dives for the deck, trading altitude for speed, and escapes. Back at Henderson Field, he climbs out of the cockpit furious. His guns worked twice, failed the rest of the engagement. He files a report, intermittent gun function, all weapons, unacceptable for combat operations. That report lands on Chessman's desk. 2 weeks later, after Chessman's unauthorized midnight installation spree, DeBlanc's aircraft is one of the first to receive the wire and tape fix. He never has another gun malfunction for the rest of his combat tour. Years later, DeBlanc will write in his memoir, "I never knew who fixed our guns, but I owe that person my life." The line is buried in a chapter about maintenance challenges, easy to miss. But it's there. The broader implications of the wire and tape fix extend beyond individual aircraft or even individual squadrons. By late 1942, the Pacific War hangs in a delicate balance. Japanese forces still control vast territories. American industrial capacity is ramping up, but trained pilots and functional aircraft remain in short supply. Every aircraft that returns from combat matters. Every pilot who survives to fly another mission represents thousands of hours of training investment. Losing aircraft to mechanical failure rather than enemy action is a strategic waste the United States cannot afford. When the gun malfunction rate drops from 37% to 4% across Marine fighter squadrons in the South Pacific, the tactical impact is immediate. Pilots gain confidence in their weapons. They engage more aggressively, knowing their guns will fire when needed. The psychological effect cannot be measured precisely, but squadron commanders report noticeable improvements in pilot performance. Men who'd been hesitant to engage, burned by previous gun failures, start pressing attacks. The improved reliability creates a virtuous cycle. More successful engagements lead to more enemy aircraft destroyed, which leads to greater air superiority, which leads to safer conditions for American ground forces and naval operations. The Japanese notice the change. Intelligence reports from late October 1942 show Japanese naval aviation units reporting increased effectiveness of American fighter aircraft. They attribute this to possible reinforcements or new tactics. They don't realize that the American fighters haven't changed, just the reliability of their weapons. This misperception leads Japanese commanders to request more fighter aircraft for the Solomon Islands theater, thinning their forces elsewhere. Strategic consequences ripple outward from a simple wire and tape fix applied in the dark by a single sergeant. The modification also influences American aircraft design philosophy going forward. When Navy engineers begin working on the F-6F Hellcat, the Wildcat's successor, they pay closer attention to wire routing and stress points. The Hellcat's electrical system incorporates reinforced connectors at all major flex points. The lesson from Chessman's fix becomes embedded in the design process, though few engineers know the origin story. This is how battlefield lessons typically migrate into formal doctrine, through quiet incorporation rather than dramatic recognition. Chessman himself never seeks credit. When the historian finds him in 1987 and asks whether he feels bitter about the lack of recognition, Chessman seems genuinely confused by the question. He points out that he was doing his job. His job was to keep the guns working. He found a way to keep the guns working. That he had to break some rules to do it was unfortunate but necessary. The idea that this warrants special recognition doesn't make sense to him. He's more interested in talking about the pilots, about how skilled and brave they were, about how young most of them were. The historian asks about the night of October 8th when Chessman installed the modification on 22 aircraft. What was he thinking during those hours alone on the flight line? Chessman says he wasn't thinking much at all. He was focused on the work. Each aircraft took roughly 16 minutes to modify, 4 guns at 4 minutes each. He had to move carefully to avoid drawing attention from the guards who patrolled the airfield perimeter. He had to work by penlight, which made it difficult to see the wire routing clearly. Mostly he remembers being tired and hoping he wouldn't drop anything metal that would clang and wake the officers. The most dangerous moment, he recalls, wasn't the installation itself, but the morning after, standing before Lieutenant Colonel Bauer. Chessman had expected anger, accusations of insubordination, possible court-martial. Instead, Bauer had looked at him for a long moment and said, "Does it work?" The question implied respect, an acknowledgement that results mattered more than procedure. When Chessman confirmed it worked, Bauer simply nodded and said to continue. That moment, Chessman says, meant more to him than any medal could have. The F-4F Wildcat is often overshadowed in historical memory by later, more capable fighters like the Hellcat and Corsair. The Wildcat was slower, less maneuverable, less heavily armed, but it held the line during the crucial months when the Pacific War could have gone either way. From August 1942 through February 1943, Marine and Navy Wildcat squadrons faced numerically superior Japanese forces and fought them to a standstill. The aircraft's reliability became legendary, its ability to absorb damage and keep flying, its rugged construction that brought pilots home. That reliability was not accidental. It was built by hundreds of mechanics and armorers like Chessman, working in brutal conditions, improvising solutions with limited resources. They worked on aircraft that had been strafed on the ground, patched bullet holes with sheet metal and rivets, rebuilt engines with mismatched parts, and kept aircraft flying long past their recommended service intervals. The official maintenance schedules called for specific procedures, specific parts, specific timelines. None of that existed on Henderson Field in 1942. What existed was ingenuity, determination, and a willingness to make things work, however possible. Today, the F-4F Wildcat is remembered as the underdog fighter that held the line in 1942, slower and less agile than the Zero, but tough and reliable. That reliability was hard-won, built not just by engineers in factories, but by mechanics on muddy airstrips, working with improvised tools and borrowed materials. The wire and tape fix is a footnote in official histories, a temporary field modification barely worth mentioning. but to the pilots who flew those aircraft, who pressed firing buttons and heard their guns answer when it mattered. It was everything. William Chessman died in 1994 at age 80. His obituary in the local Pennsylvania newspaper mentions his military service in one sentence: served with the U.S. Marine Corps in the Pacific Theater during World War II. There's no mention of the wire and tape fix, no mention of the lives saved, no mention of the night he spent on a dark flight line installing an unauthorized modification because it was the right thing to do. His tools, including the wire cutters and electrical tape he used that night, were donated to a local VFW post after his death. They're in a display case now, unlabeled, mixed in with other donated items. But somewhere in the National Archives, in the maintenance logs of VMF 224, there's an entry dated October 9, 1942. It reads, "Installed field modification TF-17, all aircraft, gun function restored, no further malfunctions reported." The entry isn't signed, but the handwriting is Chessman's. It's as close to a monument as he ever got. The question isn't whether rules should be broken. The question is, when the system is too slow and people are dying, who has the courage to act first and defend themselves later? And when they do, will anyone back them up? Chessman had that courage. Lieutenant Colonel Bauer backed him up. Together, they saved lives that official channels would have sacrificed to procedure. The wire and tape fix reminds us that warfare is ultimately a human endeavor. Technology matters, doctrine matters, logistics matter, but none of it works without people willing to see problems clearly and solve them pragmatically. Chessman saw fractured wires killing pilots. He had steel wire and tape. He put them together. It shouldn't have been revolutionary, but in the context of military bureaucracy and engineering orthodoxy, it was. Every pilot who flew a modified Wildcat carried Chessman's work into combat, though most never knew his name. Every trigger press that fired reliably, every burst that hit its target, every safe return to base, owed something to a sergeant with a toolbox and the willingness to break rules for the right reasons. That's the legacy. Not in official records or medals, but in lives saved and missions accomplished. Sometimes the most important contributions are the ones nobody notices until much later, if at all. What other unauthorized fixes from military history do you think should have been officially recognized sooner?